today we're gonna do starting with finances. We're gonna do a bunch of interest, and there's multiple things that we're gonna consider, but the simplest of that is simple interest. So we'll go over some definitions, and then we'll go over how to find the interest, and then how to find what the future value would be after a certain amount of time. So the first thing here to consider is interest. Right? Interest, depending on if you're borrowing or if you're putting it into an investment, to a savings account, interest can be good or bad. Right? So if you're putting in money into a savings account, then the higher the interest, the more money that you get out. However, if you're borrowing money, the higher the interest, the more that you're going to have to pay back. So interest is just an accumulated amount after a term, and they will have a rate. And that's calculated based on the rate and how much money you borrow or put into savings account. And that'll be on top of the amount that you either borrow or put into savings. So the initial amount that you start off with, whether you borrow it or put it into savings account, is called the principal amount. And simple interest is, so whereas in the future problems, we're going to look at interest that's compounded more frequently than simple interest. Simple interest just is interest calculated only on the principal. So simple interest means that interest is calculated only on the principal amount. So you don't accumulate more as time goes on, because simple interest means the interest is only based on the principal amount. Whereas on the other ones that we're going to look at later, we'll have some interest and then we'll increase that amount that we take the same percentage of. So it'll kind of snowball as we go along. We'll talk about it when we get there. So the formula for interest, for simple interest, is simply taking the rate times the principal amount, and T stands for the time. One thing to keep in mind is T is always in years. So when we do any of the calculations, we have to put it in terms of years. So for instance, if I say I borrowed it and my T was, let's say 120, then I don't write T equals 120, let's say days. When I plug it in, I have to convert that to years, and that's where the banker's rule comes in. So whereas we know it's 365 days unless we're in a leap year, but the banks use 360 days. So when you come across problems for our loans or savings accounts and it's in days, make sure to use the banker's days or the banker's rule instead of our common knowledge of how many days are in the year. And this is only so that the bank can make a little more money than they would otherwise. So keep that in mind. So with that, let's go on to these two examples that we have. The first one is we deposit $2,000 into savings with a rate of 6%. First part, let me separate this. Find the interest at the end of the year. So let's do that part first. So $2,000 is our principal amount. Right, so our P is 2,000, and then our rate, or R, is 6%, but as we know, we can convert that into decimals and it's 0.06. And then our time is 1 year, end of the year. So our T is 1. And we can use the formula, so I equals PRT. So we simply have 2,000 times 0.06 times 1, but we can omit the times 1 because anything times 1 will be itself. So if we do that, let me do it out here, 2,000 times 0.06. So 0, 0, 0, 12, and then, so that'll be $120 in interest. So that's a natural lead to the next question. how much money at the end of the year. So since interest is $120, we simply add that to the principal amount, which was $2,000. So the money at the end of the year is $2,120. Okay, and this is where we get our next formula. So when we want to find the future value and we let A be future value, we do the principal amount and we add the interest, right? But since we know that the interest can be calculated by doing PRT, we substitute that in. So we get future value is principal plus PRT. And if you look in the textbook, it'll factor out the P because they both have P's, right? So I can say P, 1 plus RT, is my future value. So you could use this formula to find your future value, or you could just find out the interest and then add that to the previous or the principal amount, whichever way, because that's where the formula comes from. So you could use either or. The next one is slightly different. So you're borrowing $2,500 from a friend, I think. It says in the textbook, but you pay back $2,655 at the, let's say, at the end of 6 months. Sorry, I should have had that down. What is the interest? So we have information here, but we don't have the same information as we did before. So now we have that the amount that we borrow, so the principal amount is $2,500. The amount that we pay back, so A, is $2,655, right? And then the time, they said 6 months, and we always have to put it in terms of a year, so we can say 6 months out of 12 months. And you can simplify that to 0.5 or 1/2, but you don't have to. So we want to find out what the interest is. Oh, I wrote that one wrong too. What is the interest? We want to find out the rate because we could easily find out the interest. Sorry about that. So we want to find out not the interest, but the rate. So there's 2 ways to go about it. One, you could use A equals P1 plus RT, or you can use I equals PRT, whichever one. Because if we borrow $2,500 and we pay back $2,655, from this we can deduct that, let's see, $2,655 minus $2,500. So 155 is the amount of interest that you got. So since we have that, you can just say 155 is equal to 2,500 times whatever R may be, and then times 1/2, or 6/12. Or you could go here and do 2,655 equals 2,500, 1 plus R, and then T is 1/2. Whichever way you choose to solve, you'll get to the same results. So we simplify, right? A little bit of algebra here. So 155 is 1250 because multiplication is commutative, so we can switch these two around. And if we do, we're taking half of 2,500 and then times R, right? And finally, you do 155 divided by 1250, and that's your rate. But commonly, we use percentages for rate. So let me bring up my calculator. Oh, sorry. So we're going to do 155 divided by 1250. And if we do that, we get 0.124 as our R. But we want our rate to be in percentage. So we move the decimal 2 places over. So it's 12.4% is your rate. Okay, and that's then, because we wanted to find the rate. Or you could go here and solve it, and it's the same process, right? So you could distribute first, and if you do that, you don't have to, but if you do that, is plus 2,500 R times 1/2, 2,655. And if that's the case, you're going to subtract out 2,500 from both sides, and then we end up right here. So it's up to you to do that first and then go on, or to do it after. Either way, you're going to get the same percentage at the end.